and welcome. In this video, we will look at composing functions from tables and graphs. First, let's review the definition of composition. Let f and g be functions such that g is a function that takes inputs from set A and pairs them with outputs in set B. And let f be a function that takes inputs from set B and pairs them with outputs in set C. Then we define the composition of f and g to be the new function h that takes inputs from set A and pairs them with outputs in set C. And we can denote h of t as f of g of t. And we also sometimes see the notation h equals f circle g, where f circle g is the single function f of g of t. All right, so in this example, we're going to let function f be given by the graph below and let function p be given by the table below. Compute the exact value for each of the following quantities or explain why they're not defined. So in our first example, we have p circle f of -2. We can rewrite this as p of f of -2. So to start, -2 is the input for function f. So we're going to look at -2 on the graph, and we see that the output is this closed point at 0. So we know from the graph that f of -2 equals 0. If we substitute that into our composition, that means we want to find p of 0. And 0 is the input for function p. So when the input for function p is 0, we see in our table that p of 0 equals -1. All right, the next one says f of p of 1/2. So we'll start by finding p of 1/2, and we see in the table for function p that when the input is 1/2, p of t equals 3. So if we substitute that into our composition, we're now looking for f of 3. So the output of function p is now the input for function f. And looking at our graph, when we have an input of 3, it looks like the output is just greater than 1, which if we were estimating, that'd be fine, but the directions did say compute the exact value. So what we're going to want to do is actually find the equation for this piece of function f. And so we can do that. We see that it looks like a linear function. So we're going to use point slope form. Y minus y0 equals the slope times x minus x0. If we look at 2 points on this graph, maybe 1, 1.5, and 6, 1/2, we see that the graph falls 1 unit as the input increases by 5. So the slope is -1/5, and we could use this point 1, 1.5. So we're going to have x minus 1.5, and then y minus, whoop, I have that backwards, don't I? Sorry. We're going to have x minus 1, and then y minus 1.5. So y minus 1.5 equals -1/5 x minus 1. That gives us the equation for this rightmost piece of function f. And remember, we're trying to find f of 3, so we're going to let x equal 3. And I will let you verify that that equals 11/10 or 1 1/10. So f of 3 equals 1 1/10. Remember, we knew f of 3 was a little bit bigger than 1, so now we know exactly what f of 3 equals, 1 1/10. All right, let's look at 2 more examples. So we have the same function f, same function p. Here we want to find p circle p of 1/2. So I'm going to think of that as p of P of 1/2. We already know that P of 1/2 is 3. So we can replace that inner P of 1/2 with the output value that corresponds to it, which is 3. And then P of 3 we see equals -2. All right, last example. For what values of x is P of f of x equal to 3? So now we're working backwards because we already have the output, the final output of 3. And we're trying to find the original input. So to start, we're going to think of P of what equaled 3. All right, we're trying to find the input for P that gave us 3 as an output. And we see that there's that lovely 1/2 again. We know P of 1/2 equals 3. So remember that the input for function P is also the output for function f. So now what we're actually trying to do is find where f of x equals 1/2. So if we look at our graph of the function f, here's an output of 1/2, and we see that when x equals -1, f of -1 is 1/2, and we also see that when x equals 6, f of 6 also equals 1/2. So for what values of x is P of f of x equal to 3? We found 2 values, when x equals -1 and x equals 6. I would encourage you, before you move on, to verify that P of f of -1 does indeed equal 3, and that P of f of 6 does indeed equal 3. We can check our answer that way. All right, thanks for watching.